Okay. Got 2 points. And I'll just do A, B, and C, D. We'd have numbers, so I'll do another one's numbers. Let's say the numbers are 5, 7, and 11, 14. Okay? In either case, the fundamental triangle has those points as vertices, and the hypotenuse runs from one point to the other, right? Okay? So, I've got 2 choices of how to draw the thing. I could draw it up here, or I could draw it down here. The sides have to be parallel to the coordinate axes. Well, I'll draw it up here. For no particular good reason, except I got more room to label up here. Okay? And on this one, I'll draw it like this. Totally your choice which way you draw it. Okay? Then, label the rise, the run, and the slope. Okay? So, what's the rise? Let's say for this triangle, what's the rise?
One guy parallel to the line.
Yeah, what number would you?
6.
Huh?
6.
I'd use 7. 7 to 14. You're going up 7 units, right? Make sense? Okay? But first thing you got to do is you got to decide what direction you're going. Now there's some people that made mistakes in the homework, easy to fix, by going in different directions for the rise and the run, because you weren't very specific about it. Okay? When I introduced this before, I said, well, we're going to use arrows to show what direction we go. So if you missed that, well, you didn't miss it this time, did you? So as long as you got it, that's good. Okay? What are those little details that you fill in before you try to take a test? Okay? So, from here up to here, how do you calculate the rise from here up to here? What's your calculation?
-6.
That's your result. What's the calculation?
5 minus 11.
Actually, that would be the run, because
Oh.
5 is your x coordinate. So now I see where you're getting 6. Okay, because I've heard that a couple of times, right? Now you just saw me screw that up on a big example in the last class where I used the wrong coordinates. You know, I reversed the coordinates because I was being stupid. Okay? If you do it, it's not because you're being stupid. It's because you're not quite used to it yet. Okay, if I do it at this stage, yeah, that was pretty stupid. Okay, so anyhow, we go from we're going vertically, right? We're going in the y direction. We're going to use the y coordinates, 7 and 14, right? So what's the calculation with 7 and 14?
14 minus 7.
14 minus 7. So I'm going to write that down. Okay? And that's the rise. And I probably want to put the word rise in. I want to do all of this to remind myself of what I'm doing, so that when we use this as part of our strategy to learn to interpret the real world, we can do it. Okay? So, rise, 14 minus 7 equals 7. The run is 11 minus 5, as you already told me. You thought that might be the rise. Okay? Easy to fix that, right? Run goes this way, rise, you know, might be hard to figure out which one's the run, but the rise ought to be easy, right? Goes in the vertical direction. Okay? Okay, so over here, which direction do you want to go in? Well, we usually go left to right, but if you go right to left, as long as you do it in both of them, you're still going to end up with the right answer. And sometimes you might want to do that for one reason or another, and you're free to do so. Okay? But I'm going to go left to right most of the time. Okay, so what's my run? What 2 numbers tell me what the run is?
C minus D, I mean C minus A.
I'm sorry, Dan, just a little louder.
C minus A.
Well, C and A are the two numbers, and the calculation is just kind of like it was down here, exactly what you said. It's C minus A. If you're going from A to C, your displacement is C minus A. Just like if I'm going from 5 to 11, do a run, then my displacement is plus 6, right? Now if I was going this way, I'd have to do 5 minus 11, wouldn't I? I'd have a run of negative 6, but then I'd have to go this way here, and I'd have a rise of negative 7. Okay? So they both have the opposite sign if I went the opposite direction. Okay, well anyhow, what's the rise? Well, you've gone from B to D, so the displacement is B minus D. Okay? Okay, what if I had the points 4, 3, and 19, 6? That wouldn't make any sense. Make that 4, 9, and 19, 6. Okay, if I put my arrows in this direction, what's my rise? Well, it's the 6 and the 9, and I'm starting here and going here, so it's 6 minus 9 equals negative 3. What's my run? 4 to 19, that's 19 minus 4 equals 15. Okay, so here's run, here's rise, here's run, here's rise. So what's my slope for this triangle?
7/6.
What calculation do I do to get the slope?
Rise divided by run.
I do rise divided by run. That's what slope is. That should echo in everybody's head. If it didn't, wonder what, well, it doesn't matter. Okay, so slope is rise over run, which is 7/6, right? Now, when I label that on the triangle, the convention is I put it next to the hypotenuse, but that makes it look like it's a distance, which is ridiculous because the hypotenuse has to be longer than either of the sides of a right triangle, right? Shortest distance between 2 points is a straight line. That distance has to be less than either of these. So I don't want to make it look like that. I put a rectangle around it to indicate that it's a slope. That's a convention we're going to use. It's only in this class. If you do that out in polite society, nobody will know what you mean unless you define it. But in this class, when we do the fundamental triangle, it's going to be labeled like this. Make sense? A couple other things we label, but so as not to confuse the issue. Okay, well, what's the slope here? Rise divided by run. There's your expression for the rise. There's your expression for the run. So that works for any 2 points, because A, B, C, and D could be anything. Okay? If A was 5 and B was 7 and D was 14 and C was 11, and we plug those numbers in, we would get this, right? Because that's how these were calculated. But we don't want to use this as a formula unless we're trying to do a symbolic proof or something, and we will, but we won't worry about it. Okay, anyhow, here, without going through the details, negative 3/15. Of course, what do we want to do with that? We want to reduce it. It's negative 1/5, isn't it? do your, so replace that with -1/5. Now, if you did the calculation out here, you'd say, okay, -3/15 equals -1/5. That's rise over run equals this, and we want it in Lowe's terms. Okay? Now, any question about that? You've done a lot of things with slopes, and you're doing okay with them. Okay, at least from the homework I see, I think we're okay with that. So that should clarify the first problem to where you can easily do it. Make sense? Okay.